Ready? So we go with work, energy, power. And as I said, so what we'll do in this chapter of work, energy, power is that there are two sections. Okay, if you see the chapter, there is a lot of theory portion. I'm not going to cover the theory as of now, considering exams and all coming up. So there you'll have theory on conservation of energy, what is geothermal energy, what is tidal energy. I'm not saying I'll not cover, but that's not on priority one. Priority one would be the numerical portion. So let me cover up the numerical portion properly. That is what is actually asked to in exams. And what is energy economization, what happens to, these are topics that trend in any talk show. Even if you read them, it's not that you will not understand. So let's try and see how quickly we can understand concepts of work, energy. Okay, so we start with work. Chapter is work, energy and power. The first thing that you need to understand in this chapter is that energy and work are analogous to each other, denoted by W, and this will be denoted by E. The best way to understand is the amount of energy that you have in your body is the amount of work you will be able to do, and the amount of work that I will do on you would be the amount of energy that will be stored in you. First one is easy to understand. The amount of energy that you have is what work you will do. Second one, I said the amount of work that you do. Let's just understand, if there's a spring, you compress the spring, you're doing some work on it. We'll have to understand work. What is work? When you compress the spring has got energized. Now it has the capability to do work. How? Release the spring, patak, it will just go and hit you, right? So let's understand what is work first. We say work is said to be done when point of application of force moves along the direction of force. When the point of application of force moves along the direction of force, okay, then we say work is said to be done. So let's say, for example, let's say, right, now I have a ball out here. And I apply a force F on this ball. Okay, I'm applying a force F on this ball. So in other sense, where is the force getting applied? The force is getting applied right say at the center. I'm applying a force. So the ball starts rolling. Okay, the ball starts rolling, and say that from this particular distance, the ball rolled to this particular distance, right? So we say work is said to be done when the point of application of force, this is the point of application of force, moves along the direction of force. It's moving along the direction of force, and say suppose in that process it covered a displacement of S. Okay, it covered a displacement of S. So we define work as the product of F into S. In many books you will see F into delta S. Delta S means the change in displacement. This is, suppose this was an initial displacement S1 and this is S2. So how much it got displaced. But the level at which work is being taught at your IGCSE level is very, very primitive, okay? Because slowly you will find many occasions where absolutely this doesn't happen. But let us first understand from the IGCSE perspective. So work is said to be done when the point of application of force moves along the direction of force. And numerically, work is given as the product of force into displacement. Okay, work is a scalar quantity, unlike velocity and all, which are vector quantities, but it has come up from the product of two vector quantities. Force is vector, displacement is also vector. But this multiplication, because you all don't have vector algebra, this multiplication is known as scalar product. In fact, if you are interested to go a little bit more deeper, you can go to the first video of CBSE for work. But that will just be consuming time right now for you, because this is not there in your syllabus. So two vectors can be multiplied in such a manner that you get a scalar output. So the scalar output is work. And the unit of work is not Newton meter. This is Newton, this is meter. It's not Newton meter, it's Joule. So, sir, why is it not Newton meter? Newton meter is given, you had heard about something called torque, right? Torque is force, in a proper manner, we'll say momentum into force. Now, torque's unit is Newton meter because momentum we denote as R, and this is a vector. This is just for your understanding, and force is a vector. This type of multiplication is called vector product. Vector product, and a vector product always gives you a vector. But in case of work, it is force. We don't write cross, we actually write dot S. This is called dot product. This is called a dot product, also called as a scalar product. So when you study vectors in higher classes, you will understand vectors can be multiplied with a vector product or with a dot product. When you do a dot product, then the outcome that you get is a scalar quantity. Therefore, the unit of work is Joule, and the unit of torque is Newton meter. Otherwise, if you see this is meter, this is Newton, this is Newton, this is meter. Don't write Newton meter here. This is Joule. Because iska janam hua hai after a dot product of two vectors. A dot product of two vectors always gives me a scalar. A vector product will always give me a vector. Okay. So if somebody now tells you how to define 1 joule, we will say the work done is said to be 1 joule when a force of 1 Newton displaces a body by a displacement of 1 meter along the direction. Always remember, this is very important. 1 joule when, okay, we say, if you have to define 1 joule, we say 1 joule of work is said to be done when a force of 1 Newton displaces a body by a distance of 1 meter along the direction of force. So all the Cambridge books will always tell you is that remember that F as a vector and S as a vector should be in same direction. But there is a lot of interesting thing that they could have covered in the syllabus. If you are interested, you can go down to CBSE work videos. We have actually taken 4 videos only to understand work. And today also we were doing work. So it's very interesting. So this is the definition of work, right? Force should always be in Newton and displacement should be in meters. Then you get work in joule. Another unit of work is ERG. The CGS unit of work will be work or energy is urge, ERG. 1 urge of work will be done when a force of 1 dyne moves an object by a distance of 1 centimeter. Okay? This is about work. This much is sufficient for you to target and solve any problem at your level. We'll do some problems first and see whether we are able to do. If anything extra is required, I'll definitely cover that also. Don't worry. Right? So at your grade level, you will be getting problems in which the force is always along the direction of displacement. Yes, I rahega. But you know, there are some interesting things just to open your mind for thought process. How about seeing scenarios like this? See this type of scenarios. This is a toy car. You know, a child when he plays with his toy car, how does he play? The child pulls the toy car in this direction. So which direction is the force acting? The force is acting in this direction, right? Which direction does the toy car go? The toy car goes in this direction. Here you can't apply this formula straight away, F into S. ये टाइप के प्रॉब्लम आपके पास नहीं है, ये टाइप सीबीएसई में है. अगर आपको करना है then you should know a little bit of trigonometry. End of the day you have to see how to make the force and displacement in one direction. There what we do, you again know what is vector resolution. You can resolve this vector. Suppose this angle is theta, so you can resolve the vector into two. This is with the horizontal component of F, this will be the vertical component, and then you will say the work done will be equal to the horizontal component, because that component of force which is along the displacement. ये child है, it is the outcome of FH and FV. FH is responsible for taking the cart, not FV. So when we do work, always remember take that component. But आपका component problem नहीं है because trigonometry is not introduced. So shall we do some problems from your book now? Let's do some. Can I rub this? We'll do some problems from work from your book. Can I go ahead? Or should I wait? All okay? चलो. उसके बाद एनर्जी करेंगे, पावर करेंगे, then we will go back to pressure. I will leave these parts for your study. वो how to conserve energy, what is happening on energy loss. If you think you have not understood fossil fuels, what can I teach out in fossil fuels? Okay, चलिए. Now let's say there is a body whose mass is 3 kg, right? Whose mass is 3 kg, and we are supposed to, there's a person out here, and this person is supposed to lift this body by 2 meters. मतलब 2 मीटर ऊपर लेके जाएगा, है ना? We'll take it 2 meters up, 3 kg, and this is 2 meters. We need to find out what is the work to be done. So we go back by our same definition. What is the definition of work? Work is always force into displacement. Now displacement we know is 2 meters. Now which direction is the displacement happening? The displacement is happening in this direction. Agreed? Force also should be in this direction. Obviously you also lift it in this direction. Now let's take the body just on a free state. This body will be exerting a weight which will be equal to the mass into acceleration due to gravity. Agreed? What is its weight? Its weight will be 3 into 10, which is equal to 30 Newton. Is there any issue? No issue. Now आप सोचो, आप इसको जब ऊपर उठाओगे आपको 30 न्यूटन फोर्स तो देना पड़ेगा ना, नहीं तो बॉडी नीचे चला जाएगा. So you will be applying a force of how much? 30 Newton. Which direction is your force? Which direction is displacement? Problem solved. Situation, all our criteria satisfied. अब हमारा फोर्स किस डायरेक्शन में है? इस डायरेक्शन में है. फोर्स की वैल्यू कितनी है बेटा? 30 न्यूटन. एस कितना है? 2 मीटर्स. तो वर्क डन कितना हो जाएगा? 60 जूल्स. क्लियर? अच्छा, ये प्रॉब्लम को थोड़ा सा और चेंज करते हैं, ठीक है? लेट्स से सपोज दे वुड हैव आस्क्ड यू दैट देयर आर स्टेयर्स लाइक दिस, और इस साइड का मेजरमेंट आपको दे दिया, राइट? यू हैव टू लिफ्ट द सेम थिंग टिल दिस फ्लोर एंड दे गिव यू दिस डिस्प्लेसमेंट. जैसे आपको दे दिया, अ मैन इज स्टैंडिंग से 4 meters away from the wall and the inclination of the stairs is 3 meters, okay, and he has to lift 3 kg. What is the work done? अब बहुत बच्चा क्या करेगा? Work done, force into displacement. Sir, initial is this, final is this, therefore this is हो ही नहीं सकता है. Force is in this direction, displacement ये direction में हो ही नहीं सकता है. Displacement is this one, the vertical height. So you have to first calculate the vertical height. How much will it be? Sorry, this will be 5 meter दिया रहेगा, तो ये 3 meter हो जाएगा. 3, 4, 5 is a Pythagorean triplet. So your work done will be now 3 meters into the weight 30 meters. Have you understood this type of problem? Don't go by this. Always the vertical. ठीक है, तो आओ और थोड़े प्रॉब्लम्स करते हैं. लेट्स सी सम मोर. कैन आई रब दिस? So what did you learn so far? We learned about a scalar quantity called work. Work and energy are analogous. The unit of work is joule. The smaller unit of work is ERG, erg. So what is 1 joule? A work of 1 joule is said to be done when a force of 1 Newton displaces a body by a displacement of 1 meter along the direction of force. Work is the output of scalar product of two vectors, which is force and displacement. That's why work is a scalar quantity and its unit is not Newton meter, its unit is joules. The Newton meter unit is reserved for the vector product output of force and displacement, which is torque. Clear? चलिए अब एक प्रॉब्लम करते हैं. टेस्ट योरसेल्फ. हाउ मच वर्क इज डन, यू ट्राई टू डू when a mass of 3 kg, okay, question, mass is equal to 3 kg. When a mass of 3 kg is lifted vertically, you're lifting it vertically, the lift is vertical. In fact, IGCSE part of work is very easy. 6 meter, and they have asked you to take G as 9.81. They've somehow not been very kind with you. G as 9.8. Okay, now look here, G value is given as 9.8 Newton per kg. Do you understand what is this? Newton per kg. Usually you are habituated to write G as what? 9.8 meter per second square. Newton per kg means they are trying to represent it as gravitational field. What is the weight? Gravitational force is equal to mg. Gravitational force Fg is equal to mg. Now bring Fg by m. This is called the gravitational field. This is equal to G. What is the unit of this? Newton per kg. Ultimately घूम फिर के मीटर पर सेकंड स्क्वायर हो जाएगा. न्यूटन क्या है? न्यूटन इज मास इनटू एक्सेलरेशन इनटू केजी, राइट? केजी ने केजी को कहा ना, मीटर पर सेकंड स्क्वायर. It's same. This is when you are trying to show it as gravitational field strength. The gravitational field strength is the gravitational force per unit mass. Gravitational force per unit mass. Suppose this is Earth and then around Earth there is a gravitational field. The gravitational field को ही G बताते हैं हम लोग. चलिए इसको कैलकुलेट कीजिए. पहला प्रॉब्लम. Try to do it. And even if you take these as unit, it doesn't matter because your answer वही आएगा. W is equal to क्या था बेटा? Force into displacement. You can write S or D, whatever you want. So what is your F? 3 kg into 9.8 Newton per kg into 6 meter. Kg ने kg को काटा, Newton and meter becomes joules, and rest is your answer. टफ नहीं लगा तो अभी तक? So far okay? Done. 3 10s are 30. 30 into 6, 180. 180 से थोड़ा कम आएगा आंसर. 176. Take the next one. A hiker climbs a hill 300 meter high. There is a hill. And the hill is how high? 300 meter. 300 meter is the height. And you have a hiker, and the hiker is like a Bahubali, also carrying what do you call his or her cycle with her, right? So the hiker is climbing a hill, and the hiker's mass is 51 kg. Her mass is 51 kg, and calculate she does in lifting her body. Okay, there's no cycle, so she just calculate the work done in lifting her body. That's why you sweat, yes or no? She will be sweating because she has to carry her own weight till there. G not specified out here. 10 ले लो, हो गया आंसर. क्या है? 51 into 10. So 3000 into 51 is your answer. But at that time, do write kilojoule, megajoules, whatever you get. How much is the answer? 153 with 3 zeros. So write 153 kilojoules. But when you write kilojoules, make the K in small. Work done कितना हो गया बच्चा? Work done is force into displacement. Force is mass into gravity into displacement. Mass is 51 into 10 into 300. So she said that this is 153 3 joules, which can be written as 153 kilojoules. ठीक, और एक कर लीजिए. An electric motor. So the motor is doing work now. It is lifting water. So work done is 80 joules, 80 J. Work done is equal to 80 J. The distance or the height of the lift height is 5 meters. The lift height is 5 meters. The motor does a work of 80 joules and the lift height is 5 meters. Can you calculate the weight of the box? It's actually lifting a box. A motor is lifting a box. Easy problems. मैं बोला नहीं, Cambridge में बड़ा easy है. So in the next problem, the work is given to you is how much? How much did I say? How many joules? 50 joules. 80 joules. And what is the lift? 5 meters. But you have to find out what? The weight. So the weight is equal to, weight means nothing but the force. So force is equal to work upon displacement, which will be 80 by 5, which will be equal to 16 newtons. 16 newtons is your weight. Always, and if they ask you to find out the mass, 0.6 kg will be your mass, considering 10 as your acceleration due to gravity. Kuch problem hai? Work. We'll then go to exam style questions also. Have you understood or not? That much. Let's now go to two types of energy for which we have numerical calculations in this chapter. And then we'll go to some exam style question. Then we'll revert back to all these grandmother stories of renewable, non-renewable energy and all these things. Okay. Any doubt anyone has on work? Please. But the work that has been taught to you is very, very kiddo. Okay. Chalo. Now, energy क्या होता है बेटा? Energy के बारे में कुछ concepts clear करते हैं. First of all, energy. The most kiddo definition of energy is the ability to do work. है ना? If you are a very 100% efficient system, then if you have energy worth E joules, you should be able to do work worth E joules only. You're not supposed to see. What is a machine? Let's understand here with the example of a machine. With a machine. अब machines job, अगर हम 3 idiot definition देखें, machine हर वो चीज है जो इंसान के काम को आसान करता है. It eases up. So a machine itself will not work. Machine is idiot. A machine will always eat energy, right? And it will deliver work. What type of energy does a machine usually eat? Let's say we take a drill machine. ये क्या एनर्जी पिएगा? इलेक्ट्रिकल एनर्जी पिएगा. और क्या वर्क करेगा? ये मैकेनिकल वर्क करेगा, ड्रिल करेगा, हैमरिंग करेगा, जो है ये कर सकता है मैकेनिकल वर्क. Now question arises. I told you at the start of the chapter that energy is analogous to work. आपके पास जितना एनर्जी है, you will going to do work worth that much only, and the work done on you should be equal to the energy that is gets stored in you. Before this, we also need to understand that energy can neither be created nor be destroyed. That means the total energy of the universe since the time the universe has formed until the time that the universe will one day not be there is always constant. Energy. This is the basic of what we call as law of conservation of energy. समझ में आया बच्चा? Conservation मतलब Energy is conserved like your pocket money. जितना भी खाते रहो खत्म ही नहीं होता है. But the only thing is that energy can always be converted. Energy can be converted. So let's understand that with this type of an example. A drill machine. Will the machine work if I not plug it? No, you have to plug it. Once you plug it, it starts sucking what? Electrical energy. And it is converting it into what? Mechanical work. Drill kar raha hai, theek hai na? Now question arises, how loyal is my drill machine? How loyal is my drill machine? So if you look at above, I say E and work as analogous. It means, agar ye drill machine E energy piyega, suppose this drill machine is taking 100 joules of electrical energy. My concept is it should deliver 100 joules of mechanical work. नहीं देगा. Drill machine जब हम चलाते हैं तब sound होता है कि नहीं? Or so much that our ears at least go blank. Drill machine गर्म होता है कि नहीं? होता है. Drill machine में spark होता है कि नहीं? होता है. So these are what? These are also forms of energy. Is this helping you in your work? No. This is something that we call as loss. And what you get here is your net output. So in any system, any realistic system, real scenario, tell me, if your mother feeds you 5 chapati, again same question, do you work worth 5 chapati? Never. कभी नहीं काम करोगे. Real scenario में the output that you get is always less than the input. Rather, if you want to equate them, then we will always say input is always equal to output plus losses. कुछ तो loss होएगा ही. No sir, we bought a drill machine which is very efficient. हो ही नहीं सकता है. हो ही नहीं सकता है. Losses होगा ही होगा in any system. The efficiency. So when we talk about, फिर yield की बात हो गई इसमें. ये भी yield ही है देखो. What is the yield? The yield is the output. What is the input? 1 liter milk. Losses are all water. This is the only cream that you get. So we bring a term here which is known as efficiency. Efficiency means we say, you know, take my drill machine because my drill machine is more efficient. Understand what I'm saying? My drill machine is more efficient. Okay, what is the problem with Nidhi's drill machine? Sir, it is inefficient. Means Nidhi's drill machine with the same input must be vomiting more of losses and less of usable work. What are the losses? Might be her drill machine is making more noise. Sometimes when our drill bits get blunt and we are miser, we will not replace it. So we'll go on. But what's happening? You're consuming energy. Electricity bill to aayega. Hole hua अच्छे से. First of all, the finish will not come good. So we always talk about something called efficiency, and the efficiency is a ratio of output over input. You can just think it like this. अगर आप स्कूल के जैसे देखो तो ये है आपका score over the full marks. If your efficiency is high, your घर वाले आपके ऊपर खुश है. You are a good student. Your score is nearing the full marks ना. If your efficiency is low means खूब मस्ती मारा इस टर्म में, पढ़ाई नहीं किया. And efficiency को अगर हम percentage में दिखाएंगे तो क्या दिखाएंगे? यहाँ पे 100% मार देंगे. What is your percentage score in your school? Score over full marks into 100%. अब भाई साहब यही तो उस दिन मैं yield करके चिल्ला रहा था ना. कौन सा अलग चीज पढ़ा रहा हूँ? Yield percentage is equal to yield over theoretical value into 100%. Yield percentage. Concept is same. Finance में देखेंगे तो क्या बोलेंगे? Return of investment is equal to return upon investment into 100%. This is ROI. यही बात है सर. ठीक है. तो our machine that we buy in the market will always take some energy, waste some energy, and then give you an output. If you look about your petrol engines have got an efficiency of only 20%. 20%. Just imagine, उसी में गाड़ी क्या speed जाता है. Diesel engines have an efficiency of 40%, not more than that. Means if you are spending 100 joules of chemical energy from the fuel. अच्छा यही अगर गाड़ी होता, if this is my car, if this is a car, then the car is eating what beta? Fuel. Fuel means chemical energy, right? they undergo combustion, and the car is giving you mechanical work. This mechanical work is again used to convert to electrical energy to light up all your what, bulbs and everything, air conditioning systems and all. So electrical energy we have, and some part it is rotating the shaft. And upon that you want an AC also. Already it is giving only 40%, and you want an AC to be loaded here. That too, if somebody goes to the shop, you say AC on hi rakho, I'll sit with the AC on. Running an AC in a car is the most expensive AC that you have ever run in your life. समझ में आया? अच्छा, कुछ और एग्जांपल्स देखते हैं. जैसे ये मान लो हिल है, हिल से पानी गिर रहा है, पानी गिरते ही you put one turbine wheel out here, it can rotate this turbine wheel, right? So you are using what, we'll come to this, is the potential energy of water. You are using it to rotate this, you're forming kinetic energy. इसको आप convert कर दो, लगा दो किसके साथ, generator के साथ. So we have potential energy getting converted to what, kinetic energy. Kinetic energy is now moving this generator, so you are getting output electrical energy. With that, our Madam Sahasra is enjoying a hot cup of coffee. Again what, heat energy. जैसे भी करो. And again with this some electrical energy, she is also charging her cell phone, so converting it back to chemical energy. आपकी मर्जी. Solar energy से electrical energy. All forms of energy are convertible. That's why we say, look, like sound is a form of energy also. Sound is a pressure wave. It's a sound is a pressure wave. When we talk, we are creating pressure in the input. Sound is a form of energy. So when Mahabharat wars and all happened, those sounds and what people spoke, those were also energy. They must have got converted into some form. Someday we will have some technology which can convert that energy back to sound energy, and we should be able to hear what people spoke in those days. You might be thinking I'm speaking nonsense. Let me give you a common example, as I give everyone. You know the name of Tansen. Tansen used to sing in the court of Akbar, and he said, people used to say he used to sing so nice that his rags could bring rains and all. So whenever Akbar used to be sad, Akbar used to call Tansen, and Tansen used to sing for him. He's one of the jewels of Akbar's court. Akbar ke jewel mein Navratna the, 9 Ratnas. Birbal was one, Tansen was one. And suppose I now take you for a time travel to Akbar's world, and you go and see that every time Akbar is sad, Akbar calls Tansen, and then you give a proposal. Why do you disturb this poor fellow? Why don't you record some of his songs and put it on an MP3 player? Akbar will just chop off your head. You're speaking too much than your age. But you're speaking correct. Because Akbar is in 1600, you have gone from 2024, that technology is there. है ना? आज हम सबको सुनते हैं ना, किशोर कुमार and all people who are no more there, aren't we seeing them? Yes. So one day something will come that you will be able to even extract that also. So energy can be converted. ये चीज ये सब समझ में आया आपको? तो ये था थोड़ा सा बेसिक आपको बताने के लिए. So always understand, in process there will always be a loss. In every process, whenever there is an efficiency factor, output और input के बीच में एक factor का difference आएगा, that is losses. ठीक है? Now in all these energies, we speak about mechanical energy, or mechanical energy may be two forms of energy we'll talk about, from which we get a lot of numericals and for which we can quantify them. चलें उनके तरफ. ठीक है? ये बेसिक चीज समझ में आया? Okay. For any energy can be converted. देखो, आपके पास मोबाइल फोन है. In the mobile, what type of, you have a lithium ion battery. So the chemical energy is getting converted to electrical energy using the mobile. From there you are playing songs, sound energy. मोबाइल गर्म हो जाता है, heat energy. फिर मोबाइल को चार्ज करते हो, फिर electrical energy डाला, और वो अंदर जाके क्या करता है, फिर stores back chemical energy, है ना? Now say suppose you lifted a big stone to throw on his head. So to lift the stone, we have done some work. What work did we do? We did some work. We have energized the stone. And then where did we get the energy? We burnt our calories. Burn your calories. That means chemical energy of my glucose and food. We gave energy to the stone. That will have potential energy enough to bang her head at that time. ठीक है? आइए. So जब बात करते हैं मैकेनिकल एनर्जी की, इसमें you see two forms of energy. Maybe I may differ a little bit from the book, but it's same. We say there are two primary heads: potential energy and kinetic energy. Right? Potential energy is the energy possessed by a body by virtue of its position. किसी पोजीशन में आने के लिए अगर आपको एनर्जी आ गया, ओके, दिस इज द, हियर वी से एनर्जी possessed by a body by virtue of position. Typical position, right? Marker pen on my hand, no issues. तो ऊपर कर दिया, इतना एनर्जी है कि इट कैन एक्चुअली स्ट्राइक समथिंग व्हेन इट फॉल्स ड्यू टू पोजीशन इज नोन एज पोटेंशियल एनर्जी. ठीक है, दिस पोटेंशियल एनर्जी फर्दर इज स्टडीड. पोटेंशियल एनर्जी वी डिनोट एज PE. This PE is further classified under two heads. One we call as EPE, one we call as GPE. EPE and GPE. EPE in your book will be called as strain energy, जैसा लिखा रहेगा. We call it as elastic potential energy. Elastic potential energy. This is the energy. Again, position here. The parent is potential energy. So energy possessed by a body by नहीं लिखेंगे, due to constraint. Okay, do you understand what is constraint? To understand constraint, best is watching all those 90s Bollywood movies. You will find hero two hands tied, hero's mother two hands tied, and villain is slapping the hero, heroine is dancing, and hero says, एक बार मेरा हाथ खोल दे तो मैं दिखाता हूं तुझे. So that जो बांध के रखा है ना, that is he's constrained. Since he is constrained, so he is getting a lot of energy. देखते रहना, यहाँ से एकदम खून निकलते रहेगा, anger and all. He's constrained. So best way to understand, rubber band. You take a rubber band and you stretch it right in front of somebody's face whom you like a lot, and the system is now constrained. Is it energized? Yes. छोड़ने से टपाक. Or you take a bow and an arrow, catapult, and say we were not so lucky like you guys to watch mobile phones and have food. So what we used to do, we used to have toys. बंदर, उसको चाबी देना पड़ता था. Then the bandar will do duck, 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 duck. So what are you basically doing? You are winding a coil. When you actually wind a coil, there is a metallic tin foil which gets closely wound. आपने इसको wind कर दिया. अब ये क्या चाहेगा? वापस recoil करना चाहेगा ना? You don't allow it to recoil so fast. You recoil it through small gears. So the bandar will do tick, 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 and it goes on. So these are all elastic potential energy examples. Any energy due to constraint. Look at my finger. I make it like this. Is it constrained? Paining me. Is it energized? Yes. Bring your face. Tapak. Understood? And GPE is gravitational potential energy. This is what you will be doing problems all about. Gravitational PE. This is due to the gravitational height typically, or height as we say. Zero height. Let's understand a simple thing. This is a building. This is a building. ठीक है ना? स्टोन यहाँ पे रखो. अब इसकी हाइट क्या है सर? 0 विथ रेफरेंस टू ग्राउंड लेवल. ओके, ग्राउंड लेवल के रेफरेंस में इसकी हाइट क्या है? 0. अब इसको थोड़ा सा यहाँ पे ले गए हम. We take it at a level h, or say we take it at a level x. यहाँ पे ले गया. Does it have energy right now? Yes. How to understand? Always our example is Madam Nidhi. Make her lie down and you lift the stone as much as you want above her. The amount that her eyes get frightened is directly proportional to the energy that is the stone is getting. possessed. By the time you lift it here, she must have closed her eyes, which shows that the body is maximum energized. Have you understood? And when you bring it here, she laughs because she knows that the body is not at all energized. So gravitational potential energy is what we will be doing calculations all about. Have you understood? Right. Now let us say that we have lifted this stone through a height. How much beta? H height तक हमने इसको उठा दिया है. किसको? Stone को. और stone का mass कितना है? M है. So stone is exerting always a weight. How much? mg. Do you agree or not? The stone is of mass m and it is right now at the ground. Its weight is how much? mg, acting downwards. If you want to lift this stone, then every time, अब इसको ऐसे करते हैं, देखो, इसको बढ़िया यहाँ पे एक पुली डाल दो. There is a pulley and then make one more pulley out here, and let's say a badmash like me is out here and I start pulling it. Yes or no? I have to exert a force which is equal to mg. Which direction is my force being exerted? Force for the stone. For the stone, the force is going in this direction, right? And the height is this much. So the force is mg and the height is this. The moment it comes here, the work done on the stone will be equal to how much? mgh. Do you agree? How much of work have I done by that time? mgh. Imagining that there is no heating of rope, थोड़ा heat तो होगा, यहाँ पे friction होगा. Let's say there is no friction. तो ये work कहाँ से आया? भाई साहब, मैंने जो ये पसीना बहाया ना, वही इसमें आया. I have designed this system for this girl, na, so that it goes up. So somebody has to sweat up. How did they? So this is the work done. अब यहाँ पे अगर कोई energy पूछे मुझे, energy and work are analogous, so the energy is mgh. And what is this energy due to? This energy is due to a gravitational height. It's due to a height. So this is nothing but my gravitational potential energy, which is always the formula is mgh. Mass into gravity into height. Did you understand this thing or not? This part is only for your theory. इसमें problem नहीं आते बेटा. ये what is P? Potential energy is energy due to position. That position may be because ऐसा करके रखा है, constrain करके रखा है, छोड़ते ऐसा हो जाएगा. That is also a position. This is also a position. ये position में vertically ऊपर जाने के लिए आपने कितना work किया? Force in this direction. I am pulling in this direction. But the force is in this. For the stone, the force is in this direction. Displacement in this direction. So what is work done? mgh. And work itself is, देखो ना, work done को हम देखेंगे तो क्या लिखेंगे? Force into displacement. What is the force? mg. What is the displacement? h. So this work is analogous to energy. This is stored as energy, and this energy is potential energy. Rather, we call it gravitational potential energy because this pertains due to height. समझ में आया आपको? Is this part clear? Energy possessed due to position. This energy can, however, your book will straight away teach this energy separately, this energy separately. बातें, problems उसके ऊपर आएंगे. ठीक है? थोड़ा सा kinetic energy समझ लें, and then we go for problems on both type of energy. ठीक है? आओ, ये कहानी मिटाओ. All right, very good. चलो, काइनेटिक बोलते ही क्या समझ में आता है? काइनेटिक होंडा स्कूटर. काइनेटिक means anything that is moving. Kinematics. Kinetic energy is the energy possessed by a body by virtue of motion. So very interesting. अगर आप रेस्ट में हैं तो आपके पास काइनेटिक एनर्जी नहीं है. रेस्ट में है तो आपके पास पोटेंशियल एनर्जी हो सकता है. In what form? Sir, if I'm in rest and I have been constrained, then I've got elastic potential energy. If I'm in rest but I'm right now at the branch of a tree like an apple hanging there, I've got gravitational potential energy. But if I'm in motion, then I am having kinetic energy. Sir, can I have both? Why not? Why not? Our friend Nidhi, take her to the top of 18th floor, drop her from there, and she is somewhere in 15th floor. She's still at a height, so she has potential energy, and she's coming down, so she's in motion, so she has potential energy. We'll see that also. Hey, a body can have both together at a time. क्यों नहीं हो सकता है? बिल्कुल हो सकता है. हाँ जी, फिर से बोलिए बेटू. How it can have both? उसको ऊपर ले जाओ, बिल्डिंग के ऊपर में. All potential energy. अभी धक्का दे दो बिल्डिंग से. She's somewhere at 16th floor now, floating in the air, still going down. So she's still at a height from the ground, na? So she still has potential energy, and she's going down, so she has kinetic energy. Slowly, what will happen? Once she goes and crashes down, her potential energy will become zero because there's no more height. But her kinetic energy will be huge because you make Ahiri lie down there and make her fall on Ahiri now. से मारेगा जाके. So she will transfer her energy to the other person. So what happens? Potential got converted to kinetic. और लास्ट में सर काइनेटिक क्या हो गया? हड, साउंड, हीट. एनर्जी कहीं ना कहीं तो कभी खत्म नहीं होता है, ठीक है? मोशन. अब इसका though the derivation is not there, we will derive it. We'll see how to get the derivation. Okay, let us say consider this as some medium. क्या medium? सर आप खीर समझ लो, खीर समझ लो, whatever it is, condensed milk, anything, just consider this as some medium, right? And I have a ball out here which now wants to enter this kheer wala medium. The ball is coming with a velocity of v. Yes or no? So the kheer medium will be obstructing the ball with a force F. Yes or no? Yes. Ultimately, the ball will penetrate this particular kheer and come at a place where its velocity will become 0 meters per second. Do you agree or not? Right? Let us say that the distance that this particular ball has traveled in this kheer medium is s. Right? The force is acting on this side. That means there is an acceleration which is acting on this side. So for the ball, the acceleration will be definitely negative, and it is acting on this side. Negative acceleration is this side. Actually, the acceleration is on this. Is this concept understood? A ball enters a medium. The medium is giving some sort of a resistive force. This resistive force weakens the velocity of the body in such a manner that it comes to 0 over a distance s or a displacement s. So don't you think it is encountering deceleration? Yes. Force is in this direction, so acceleration should be in this direction. But I'm observing it from the ball's perspective. So for me, the acceleration is कैसा? The acceleration is उल्टा. उल्टा है ना? तो ये मेरे लिए negative acceleration है. मेरे लिए the acceleration, if I show the direction this side, I have to put it as negative, right? Agreed. Now imagine, had this ball been you, and you are made to walk through some what? Say muddy terrain. Won't you sweat after some time? What is the work you are doing? You are doing the work against this resistive force. If we are, this is drag जैसा ना. अगर ये drag नहीं देता अपन आराम से जाते, अब जा नहीं सकते. So you are doing work against this force, right? So work done will be the force into the displacement. Against this force you are doing the work done, right? अच्छा चलो. अब जरा s को कैलकुलेट करने की कोशिश करते हैं. We know our equation v square is equal to u square plus 2as. This is the equation we have, right? Can we apply this here? Oh yes, acceleration is constant, straight line motion. What is the final velocity for our case? 0 square. What is the initial velocity? V square. It's coming with v. It is coming with v. V means generic. I have to take some data, so I have taken the velocity as v. Okay? Plus 2. What about the value of a? Sir, negative a into s. Clear? So what do I get the value of a as? A will become v square by 2s. जरा देखो तो ये इधर नेगेटिव होके आ जाएगा, नेगेटिव कट जाएगा, v square by 2s. ठीक? क्लियर? डन सर? Satisfied? Very good. So what did we write? Work done is equal to force into displacement. What is the definition of force? Force is mass into acceleration. Mass into acceleration into displacement. Mass Ravi Teja. Okay, so m का m ही रख लो. A के लिए क्या लिखे बच्चा? और इसके लिए s लिख ले. काट दे. कितना आ गया? W is equal to half mv square. Now you will right now say, sir, it is very easy. I understood, sir, because you said work and energy are analogous. So we can say that energy is half mv square. And since right now body is in motion, this energy is nothing but kinetic energy. So kinetic energy is equal to half mv square. We have learnt in school. लेकिन थोड़ा और अच्छा से पढ़ते हैं. समझ में तो आ गया. This is the reason. Now imagine ये बॉल वर्क किया यहां तक जाने के लिए. That work was MAS, which is half mv square. Where did you think the ball got the ability to do the work? By spending his kinetic energy. The ball was in motion, and with its motion it could penetrate this much. Where did it get its strength from? Kinetic energy. So we say this work must be done by the body by exhausting all the kinetic energy that the body had. Therefore, we say kinetic energy is definition as half mv square. समझ में आया? Now some interesting thing. If you double the mass, look at this expression. If you double the mass, the kinetic energy gets doubled. Me running with v velocity and a person double the mass of mine running will have double the kinetic energy. Kar lo na. But if somebody doubles the velocity, the kinetic energy quadruples. Just see. Let's say somebody is running with a velocity which is equal to 2v. So what is the kinetic energy? Ke dash is equal to half m v dash square, which is equal to half m. What is v dash? 2v square, which is equal to half m 4v square, which is equal to 4 times of half m v square, which is equal to 4 times the initial kinetic energy. ये क्वेश्चन पूछ लेता है लेकिन if mass is doubled, kinetic energy is doubled. If velocity is doubled, kinetic energy becomes 4 times. If mass is halved, kinetic energy is halved. If velocity is halved, kinetic energy reduces by 1/4, not half, 1/4, क्योंकि स्क्वायर होता है इसका. समझ में आया? Very good. And if somebody tells you that there is a body, look, there is a body, mass m, right now velocity is v1, and a force is acting on it. A force is acting on it. Look, a force is acting on it. Will the velocity of the body increase or decrease? Increase. So it goes and acquires a velocity v2. Obviously v2 is greater than v1. So what is the change in kinetic energy? The change in kinetic energy will be equal to half m v2 square minus v1 square. Final minus initial. Is this too tough to understand, or should I break and write it? Final kinetic is half mv square v2 square. Initial is half m v1 square. इससे ज्यादा और कोई मैथमेटिक्स नहीं है. थोड़ा सा समरी लिखने प्रॉब्लम करने से पहले आइए. So the formulas that you need to know, obviously, whatever formulas you have learned so far, what all have we learned so far? V equal to U plus AT, number 2, S equal to UT plus half, AT square, number 3, V square equal to U square plus 2AS. Then what did you learn? Force equal to mass into acceleration, potential energy, work done is equal to force into displacement. Then potential energy, gravitational potential energy is magaha, and 7 kinetic energy is equal to half m v square. And in these 3 things, work and energy are interconvertible. ये सब जरूरत पड़ सकता है कोई भी प्रॉब्लम सॉल्व करने के लिए. ठीक है? Understood? Shall we take a problem? Chalo. Let's take some problems. Okay, chalo karo. Kinetic energy of a football, mass 0.4 kg. Question. What kiddo questions? Mass 0.4 kg and moving with a velocity of 20 meters per second. Okay, we'll find out the Ke. क्या है Ke? Half mv square. So that is half into 20 v square. V square को कैसे लिखोगे इजी करने के लिए? 0.4 0.16. So 10 into 1 0.16, it will become 1.6 joules. Huh? Oh, I squared the ulta one. Yes, Hagya. So it should be half into 0.4 into 20 to 20. So you make it 10. So this becomes 4 into 20, which is equal to 80 joules. Okay. Would you like to do one potential energy problem? Calculate potential energy gained by a 0.1 kg mass, 0.1 kg mass raised vertically by 1 meter. 0.1 kg raised by 1 meter. .1 kg .1 kg raised by 1 meter. आ गया? Some more. Okay, let's do. This has got quite some parts in it. A boulder of mass 4 kg. Boulder तो पता है ना? Big stone. Boulder of mass 4 kg rolls over a cliff. Rolls over a cliff, and reaches the beach below with a velocity of 20 meters per second. So the problem is like this. This is a cliff, and you have a boulder out here, and it starts rolling, and it comes to the beach. That's at the ground level. And this boulder is how much? 4 kg. The velocity here is equal to 20 meters per second, and the mass of the boulder is 4 kg. 4 kg, ठीक है ना? 4 kg. Find the kinetic energy of the boulder as it lands. First part. First part is Ke. Children, for next 2 classes, we will keep chemistry only because we are quite ahead in, physics only because we are ahead in chemistry. We'll be able to complete your pressure तक हो जाएगा आपका एग्जाम से पहले. ये हो ही गया, इसमें और कुछ नहीं है, अभी आपके प्रैक्टिस के ऊपर है. हाँ भाई, why should you not have? You आराम से 1 hour you can relax with me. I always give nice examples. Okay. हो गया, Ke निकल गया बच्चा. K is half mv square. कितना आया? Half into 4 into 20 into 20. कितना? इसमें 10 करके कर लो. 4 into 20 is 80. 80 into 10, 800 joules. 800 joules. Okay, next. Potential energy of the boulder when it was at the top of the cliff. Potential energy of the boulder when it was at the top of the cliff. How will you calculate? Then if you have understood the chapter, you should be able to say it. What is potential energy's formula? mgh. How will you use displacement out here? क्यों displacement? It starts rolling. आपको क्या पता कहाँ आप displacement use नहीं कर पाएंगे, कैसे करोगे? There are two ways you can do. आप एक बेसिक चीज नहीं सोच रहे हो जो मैंने अभी इतना देर पढ़ाया. It has nothing to do with the previous day's class. Potential energy is what? mgh. You are stuck up with h. You cannot get the value of h by these formulas, because if you want to use this formula, then you need time. What is the kinetic energy here? 800 joules. Where did 800 joules come from? Where did 800 joules come from? Convertibility. Once it had all potential energy here, entire potential energy got, see, ऐसा चीज में हमेशा याद रखिए, यहां पे P हो जाएगा मैक्स, K क्या है? लड्डू. यहां पे P हो जाएगा 0, K हो जाएगा मैक्स. तो आपका मैक्स K निकाल लिया ना, तो दोनों एक ही है. So the P is how much? 800 joules. Yeah. Applying conservation of law of conservation of energy, P is how much? 800 joules. Now the third part is find the height. Find the height. Now you can find the height. Yeah, height is equal to PE upon mg. PE you know as 800, m you know as 4, g you know as 10. 10 ने इसको काटा, 420. So 20 meter is the height. एक छोटा चीज और बता देता हूं तो आपको सारा क्वेश्चंस, there's nothing that I need to teach in this chapter anymore from exam perspective. You still read the theory, those things don't understand, let me know. One more thing, okay? What did you understand out here? P, potential energy, this type of examples, potential energy is maximum, kinetic 0. बॉल कहीं ना कहीं बीच में यहां भी तो आया होगा ना, यहां पे भी एक PE रहेगा, यहां पे एक KE भी रहेगा. Why? Because the ball is still in motion and the ball is still at a height from the ground level. Do you agree or not? So, but our law of conservation of energy tells us that energy cannot be created nor be destroyed. It can only be converted from one pole. But here you will see that at any time the total energy remains same. बड़ा मजेदार. 3 minutes लगेगा, जरा देखो खाली. Let's say this is a height of a building, right? We have a ball which is right here at this level. We will take a level somewhere here and we will also analyze here. We'll see what happens to the total energy. Conservation says that energy cannot be created nor be destroyed, right? And let's say that the total height of the building, let's say the total height of the building is h and this much height is say x. तो ये वाला कितना हो गया बेटा? h minus x. Clear है? Right? This is mass is m, m, m. We will be analyzing at 3 positions. One somewhere midway and one right at the bottom. Agreed? So we are observing it for position number 1. At 1, the height, what is the height equal to? H. What is the velocity equal to? 0. Do you agree? Okay. So if you look at the kinetic energy here, then it is half m 0 square, which is 0. At 1, right? 1 means we're doing this at the top. If you look at the potential energy out here, it is mgh. Agreed? If you look the total energy of the system, then it is PE plus KE, which is equal to mgh plus 0 equal to mgh. Done. So here the total energy of the body is how much? Mgh, which is exactly as per our way. that it only has potential energy and no kinetic energy. Satisfied? Chal. Now number 2. 2 is somewhere in between. Somewhere in between. Agreed? So let's see what will be the velocity out here. Let's calculate what is the velocity. How to calculate the velocity? The initial velocity was how much, bacha? 0. And what is the velocity out here? So this velocity v should be equal to u plus at. हम वो नहीं लगा सकते, हम ये लगाएंगे v square is equal to u square plus 2as. ये फॉर्मूला लगाते हैं, चलो ठीक है. So v square should be equal to u square, which is 0, plus 2 into g. A is the g, acceleration due to gravity, into s. S is the distance that it has traveled. What is the distance it has traveled? H minus x. Agreed? So v square is equal to 2g h minus x. Fine. I'm not doing v because for kinetic energy I need v square only. So let's find out the kinetic energy at 2. It should be equal to half m v square, which is equal to half into m into 2g into h minus x. Clear? Half cancels away half, so it becomes mgh minus mgx. Satisfied? mgh minus mgx. Let's find out what is the potential energy out here. Potential energy के लिए हम देखेंगे जमीन से कितना हाइट पे है, जमीन से कितना हाइट पे है. So potential energy will be mgx. Now try to find out what is the total energy at 2. The total energy at 2 is equal to mgx plus mgh minus mgx. Oh wow, it's still coming mgh only. So here also the energy is how much? mgh. Energy is conserved. इन दोनों के बीच में चेंज वेंज हुआ, लेकिन ओवरऑल एनर्जी स्टिल सेम. अब एकदम नीचे देखें, at 3 the height has become equal to 0. हाँ बोलो बेटा, कुछ बोल रहे हो?
Yes, sir, but what's in the second one? It still has kinetic energy there, or it doesn't?
It has. Its kinetic energy is mgh minus mgx. Its potential energy is mgx. Total energy is still mgh.
Okay.
ठीक है? At 3 h has become 0. There's no height. And the velocity, अगर हम velocity को देखें तो कितना होगा? इतना travel करके आया. V square will be equal to 0 square plus 2 into g into, now the height is complete height, 2gh. Agreed? अभी k निकाल लें, half mv square. So half into 2 half into m into 2 into g into h. ठीक है ना? ये कट गया, कितना आ गया? के mgh. और p तो 0 आएगा मैडम, mg into 0 because the height is 0. टोटल एनर्जी कितना आया? mgh. These things should be covered, नहीं तो क्या फिजिक्स पर. So if you want to see it like in a graph system, it is something like this. This will answer Ashmita's question. Let's say this is P. ठीक है ना? So potential energy क्या होता है बेटा? जैसे जैसे बॉल गिरता है potential energy नीचे आता है, ऐसे आके potential energy क्या हो गया बेटा? 0 हो गया. और ये है हमारा के वाला चार्ट. के 0 से चढ़ना शुरू करता है और जब ड्रॉप हो जाता है तो के मैक्स हो जाता है. आप जो पूछ रहे थे somewhere midway, yes, it has potential also, it has kinetic also, but the sum is same. 6 रुपया ही रहेगा. कभी मैं 0 आप 6, कभी मैं 1 आप 5, कभी मैं 3 आप 3, मैं 3 आप 3, कभी मैं 5 आप 1, पर 6 ही रहेगा हमेशा. There is nothing more to teach in this chapter. Considering this, rest part is theory. We'll continue with this tomorrow also. Take some time to do some problems tonight. If ma'am has given a worksheet, don't jump to anything else. Try to do problems on conservation of energies and all any numerical. should you get stuck up, bring it up tomorrow, and then we go to pressure also from here. Let's wind it up and then we come back and attack the theory part जो हमारा रह गया है ना, renewable, non-renewable. I think all of us can do. Spring constant and area under the graph for motion. भर के है, हाँ, tonight only. At night I become like a Dracula, lot of energy. Anyone has, this girl will send me some worksheets, na? She will send worksheet, half sleepy worksheet from one photo, question paper some other. Then I'll hunt the question paper and I think I am sleepy. Then I cross check again, then I find नहीं she was sleepy. कुछ भी एक फोटो भेज देता है. ठीक है, चलो